Okay, physics fans, welcome back. We're going to be doing example number 2 here. And let's just see if I can scroll back to the previous notes. There was 2 ways to handle it. Okay, conservation in 2 dimensions. In the way that we just did in example number 1, we broke it up into its x and y's and did it kind of separately because there was a weird angle, 37 degrees and stuff like that. But if we can make a right angle out of it, we're doing this still, but it goes much quicker. Let's just take a look at example number 2. And I can't believe this is a 7-mark question. It's so easy. Sally is driving south in her 2,500 kilogram pickup truck at 3.8 meters per second when she collides with Willie driving west in his 1,200 kilogram car at 4.5 meters per second. Boom. The 2 vehicles lock together and slide over the wet parking lot. Find the speed and direction of the damaged vehicles immediately after collision. Why do they say immediately after collision? Because then there's going to be slowing down because of friction. They don't want that. They just want to know what the resultant velocity right after collision is. Okay, so let's just get these momentums just quickly. And it's 2,500 times 3.8. This guy's momentum, P equals mv, and mass is 2,500 times 3.8. So this guy's momentum is 9,500 kilograms meters per second south. And this is 1,200, clear. 1,200 times 4.5, and that's 5,400. So P equals mv, mass is 1,200 kilograms, and the v is 4.5. So we get 5,400 kilograms meters per second west. So after they collide, one's going this way and the other one goes this way, the wreckage just starts to slide this way. So the momentum going down beforehand was 9,500, and the momentum going left is 5,400. The mass of this wreckage, is going to be both of them together, which is 3,700 kilograms. And that mass is going to be moving in a particular direction and have a momentum that has a component of 9,500 south and 5,400 west. It's just going to combine those momentums to get that one object. It's going to actually be sweet and simple. Okay, I think so. Of course I think so, because hey, I'm the teacher. So let's just zoom off of this a bit, back off to like 150, so I have a bit of room without losing all the data. So it's going to have 5,400 this way and 9,500 this way. Heavier truck going slower, but much heavier, more than twice as much. So the resultant vector velocity that we want is this thing. So Pythagorize this out, and that's going to be 5,400 squared plus 9,500 squared, all square rooted. And then we'll do the inverse tan of 9,500, the y over the x, because that's always the angle against the horizontal. So the vertical is always going to be the opposite. So it's always this, the y over the x. And then once we get that, we have to divide by the mass. But we have to do the vectors not in velocities, but in momentums, else it doesn't work out. So the square root of that number squared plus that number squared. And that's going to equal, the momentum vector is going to equal 1,927 kilograms meters per second at an angle of inverse tan of 9,500 divided by 5,400 is 60.39 degrees south of west. And then I just take this number and divide it by, take that number and then divide it by 3,700, which is the mass. Well, the work for that is velocity vector is equal to the p vector divided by the mass, and that's 3,700 kg, the mass of the wreckage, the combination, and we get the velocity of 2.953 meters per second at an angle of 60.39 degrees south of west. Sweet. So it's much easier. You don't have to do the x and the y's and do all that, because there's only one thing in the x and there's only one thing in the y, and afterwards there's that one object. So it's pretty sweet, pretty easy. That's how you do the right angle one. And that's it. Thanks. Enjoy. Start doing some questions from the workbooklet. I'll assign. So subscribe, like my video. Here comes the jingle.